All right, let's continue and look at the problem dealing with how many, actually it's kind of worded wrong. It says how many digits. It really should say how many numbers you could make. How many numbers, I just noticed that. All right, so we're using only the numbers 1, 2, 3, 4, and 5. And we're trying to create two-digit numbers from those. Two-digit numbers, so that's number 6. Okay, since it was just 2 digits, we could use a product table. Could do something else, but I'm going to use a product table. And I'm thinking about how I have the option of 1, 2, 3, 4, or 5. 2, 3, 4, or 5. It didn't mention any different restrictions. It just wanted us to list all the two-digit numbers we could make. I'm going to think about this one being in the tens place, and this one is being the number in the ones place. Okay. So for instance, if I had a number like 85, that's the tens place. 8 is an 8, it's really 80. And this is the ones. Okay. So then I'm going to take the 1 from the left and put it with the 1 from the top. So 1, 1, 1, 2, 1, 3. And instead of thinking of them as two separate digits, I'm making the numbers 11, 12, 13, 14, and 15. Then I'm going to take 2 for the 10 spot and then pull those numbers from the top. So we'd have 21, 22, and so on. Let's do that with 3 in the tens place. So these are all the possible numbers. There were no additional restrictions listed. So I'm going to finish this. And then inside the body of the product table, I actually have all the possible results just sitting right there in case they ask me any follow-up questions. Okay, so we can see there's 25 possibilities. So how many different numbers were there? There's 25 different numbers. You know, there's 5, it's 5 by 5, so there's 25. How many are less than 30 would be the ones in these first 2 rows. So there would be 10. How many are odd? To be odd, your digit in the ones place has to be odd. So that would be 5 plus 5 plus 5, or 15. So that's the kind of thing you're doing in Chapter 10. Then in Chapter 11, we ask for the probability of getting numbers that are less than 30 in this situation. And then you would say, well, there's 10 out of the 25 possible numbers, and you'd reduce that. So that would wind up being 2/5. Or the probability of getting an odd number. So if we had all of these numbers in a bag and we reached in and pulled one out, what would be the probability we'd get an odd number? That would be 15 out of 25. And you would reduce that by dividing by 5, top and bottom, and you'd get 3/5. Okay. Now 7 is changing things up a little bit. Here we're trying to create 3-digit numbers. Because they're 3 digits, can't use a product table to do that. But I can kind of think about the tree to start what my strategic plan is going to be, what my systematic plan is going to be, and then I might be able to just list them. So I'm just going to kind of ponder what the tree would look like. So for the first digit, which would be the 100 spot, I have a choice of those 3 numbers. Then wouldn't I have 3 off of each of these with those 3 numbers? And then I would have 3 off of each of those all the way down, right? So I'm not going to finish it. I just want you to imagine it. Just get started on it. So when I go to make my list, I can think about this. 1, 1, 1. That would be one number, 111. Then 1, 1, 2. And then 1, 1, 3. And then once you get the hang, or once you see kind of a pattern emerging, you can kind of just think about, right, so I've done all the ones that start with 1, 1. So now what I'm going to do is I'm going to do 1, 2. So when I do that, that could end with a 1, that could end with a 2, that could end with a 3. Then I'm going to do 1, 3, which could end with a 1, a 2, or a 3. Now on this one I should have mentioned, this one says repeated digits are allowed. So that means if I used a 1 here, I'm allowed to use it again anywhere in the problem. Okay. Now, I need to keep going because I could have started with a 2, couldn't I? So if I started with a 2, then I could have done 2, 1, 1, 2, 1, 2, 2, 1, 3. And then I could have had a 2 in that second spot. So start with a 2 and then 2, 1, 2, 2, 2, 2, 2, 3. I'm trying to follow the pattern that I did earlier. Notice what I'm doing now here is like that one, except for that one has a 2 in front. Okay, and then I could start with a 2 and go to a 3, followed by a 1, followed by a 2, followed by a 3. Now I have one more chunk I need to do. I need to do this chunk that I would have had. So think about it. I don't want to have to actually draw it, but can you picture it? Can you think about it? It'd be 3, 1, 1, 3, 1, 2, 3, 1, 3. So again, it's the same as the patterns I'm getting here. It's the same as those, except for whatever was in the first spot, okay, is now going to be a 3. So then 3, 2, 1, 3, 2, 2, 3, 2, 3, and then 3, 3, 1, 3, 3, 2, 3, 3, 3. So I wind up with quite a bit. I can see them. I've listed all the results. And there are 9 plus 9 plus 9. There are 27 different numbers that I could make from just the digits 1, 2, and 3. Okay. Now, the second problem tells us that repeated digits are not allowed. So for that one, for the first digit, I could have used a 1, a 2, or a 3. So that's for the first digit, the hundreds place. When I go to choose my second digit, I can't use a 1 because it told me that I couldn't repeat digits. So that would be a 2, then a 3. If I use 2 the first time, I can't use it the second time. So oops. So that would be a 1 or a 3. 3 the first time, then I would only have 1 or 2 as possibilities for the second digit. Second digit. Now think about the third one. For the third one, if repeated digits are not allowed, then I'm assuming that means anywhere. So like I already have a 1 here and a 2 here, so that means all that's left is a 3. If I have a 1 and a 3, all that's left is a 2. Okay, so think about that. 2, 1 would have to end in 3. 2, 3 would be followed by a 1. 3, 1 followed by a 2. 3, 2 followed by a 1. I can't repeat a number that was used anywhere else. So I get way fewer. I get 123, 132, 213, 231, and then 312 and 321. And notice that if possible, sometimes I like to do that. See the end of the tree? Like I had this tree going. Okay, let me show this. Got that tree going. Okay, and if I followed the branches and just followed the branches all along, that would be what's at the end of the branch that ends with that 3. So it's sometimes fun to kind of line them up right with the end of the branch if possible. Okay, so you see on that how that turns out to have 1, 2, 3, 4, 5, 6. 6 different numbers could be made. This one said repeated digits were not allowed, so you couldn't reuse a number that had been used anywhere else. Okay. Now, there's a lot of problems like this in homework, so I want to look at one of the situations that comes up. What if you were using the numbers 0, 1, and 2? And we're going to allow digits to be repeated, but we're just using these 3. When you think about that, you might think that you could go 0, 1, 2, and then just do those 3 again, right? And then those 3 again. But just think about even that first branch. Is 0, 0, 0 really a number? Okay. Or what if I had 0, 0, 1? Isn't that really 1? 0, 0, 0 is a number, but isn't it just 0, right? Or like if I were down here. Oops, 0, 1, and 2. And I looked at this number, it'd be 0, 2, 1. Isn't 0, 2, 1 really just 21? And the question up here was, list the 3-digit numbers that could be made. So we want to make them 3 digits. So the question is really still, how many 3-digit numbers? So there's going to be some problems where one of the numbers you're allowed to use is a 0. But if so, it can't be in that first spot because then you wouldn't really have a 3-digit number. Okay? So if we were doing that one and we were thinking about it with the first number being the hundredths spot, the only options for the hundreds place would be a 1 or a 2. But then for the tens place, you could use any of those. And for the 1 spot, you could use any of those. I'm not going to finish the tree, but I want you to think about that while we make our list. Okay, so the numbers would be 1, 0, 0, 1, 0, 1, 1, 0, 2. So 100, 101, 102. That takes care of this chunk right here, right at the top. Then I could follow the 1 and have a 1 in the second spot, and then a 0, 1, 1, 1, 1, 1, 2. Okay, and then I could do the same with a 2 in the second spot. Okay, and we were allowed to reuse digits, so it's okay to have 2, 2 or to have 1, 0, 1. Okay, now I'm going to do the same thing, but I'm going to move down to having a 2 in the hundred spot. So 2, 0, 0, 2, 0, 1, 202, 210, 211, 212, where the hundreds could be 2 and the tens could be 2, and then I could have 220, 221, 222. So for that one, I'm going to wind up with 9 and 9 or 18 different numbers. Okay. All right.